Hi everybody. My presentation on my thesis report is entitled The Atmospheric Carbon Dioxide Capture Capacity of Construction Suitable Absorbent Calcium Hydroxide Bricks Used in Direct Air Capture Systems. And it summarises my report and its components and the importance of the research question and the need for the research. First up, we'll talk about the context and significance of the field itself. So direct air capture in itself as a technology sits within the context of global climate change. There is an acceptance now globally that emissions reduction in isolation will not be enough to ensure that the dangerous effects of carbon dioxide in climate warming will be controlled. Um, that means that something else has to be part of the equation, and negative emissions technologies are that solution. So negative emissions technologies have the capacity to actively or passively remove carbon dioxide from the atmosphere, as opposed to emissions reductions, which obviously just reduces our emissions. NETs, which they're termed, have the ability to help us as a global network to reduce global temperature increases to below 1.5 degrees Celsius. Direct air capture, DAC, is a critical component, a critical NET, which will play a very important part in the control of that temperature increase throughout the next several hundred, if not thousands of years. It's commercially viable and it's got scalable status as well too. So there's an image there of a direct air capture plant in Iceland, which is commercially at commercial stage at this point in time. Within the field of DAC, we've got the absorbents. So the field that we'll be focusing on is calcium hydroxide absorbents used in DAC to essentially remove the carbon dioxide or scrub that out of the air that the plant sucks through it. Just reduce that size. Okay, so the current situation in the literature, there is significant levels of research, particularly around reducing the costs of DAC. There is very high costs, particularly around the amount of energy that DAC uses. You can see there a trial, or not a trial plant, but a fully commercial plant in Texas in the USA, which is under construction and due to be commissioned later in 2025, so very fresh. So there has been significant research around the cost reductions, primarily focused on reduction in energy inputs or manipulation of that element, particularly around renewables and passive CO2 removal. A couple of number of papers there that are referenced in our report as well too. Another avenue of interest, which is the direction of our thesis, is for reducing DA cost per unit of CO2 removed via a dual solution, which provides for both carbon removal from the atmosphere through the calcium hydroxide absorbent blocks within the DAC. The carbon sequestration function is provided by those blocks as well. So, and those blocks, those carbon dioxide blocks, are then used or potentially used or on-sold to the construction industry for building and construction purposes. The thesis direction, there's been previous work to assess the feasibility of calcium hydroxide bricks as byproducts of direct air capture. This previous work was previously limited to modelling only. Our research sought to replicate previous similar studies of lime-based materials and their ability to absorb CO2. And there's some of the directions that we've taken and some of the papers there reference to empirically determine whether the absorbent calcium hydroxide bricks will serve their purpose. But importantly, what we're looking at too is involving a qualitative aspect, which will determine via the opinions of various building and construction subject matter experts as to whether those bricks that have been theoretically modelled will determine whether those brick sizes or if not then which brick sizes are suitable for safe and reliable use in the building and construction industry. The research design, we've incorporated a mixed method exploratory research design with an initial qualitative design component, which leads into an experimental component. There's a range of interview and survey type questions for those building and construction SMEs, and the feedback gained from that will be used to guide the sizes of the bricks and blocks that will be essentially tested in the laboratory. Only 8 SMEs will be used, and we will seek those SMEs out as particular experts in bricks and blocks from the various industry bodies. An example of the interview type questions and themes there up at top right. The experimental component, with those bricks that have been selected through the guidance of the SMEs, there'll be a control condition of 3 extruded calcium hydroxide bricks of the exact same dimensions of porosity that were measured by some of the authors that we're basing or trying to replicate their research, but with different components. And the experimental condition will include 3 calcium hydroxide brick size variants driven by the SME feedback of 3 shape variants per size variant, so a total of 9 units. All bricks will have identical porosities within the 0.2 to 0.8 range as per the previous research. Some advantages and disadvantages. The qualitative component data drives the brick size and shape options used for the experimental component, so we get the best of both worlds there. And the experimental component has the ability to heavily replicate some of the previous successful work of others in that empirical space. Some limitations are that there's no testing of the CO2 capture capacity of the experimental calcium hydroxide bricks in an actual DAC plant. And further to that, the qualitative component possesses subjectivity between humans generally and their experiences, which may guide their decisions and recommendations. Thank you for your time.